Good morning, everyone. So today let's solve some problems from three-phase induction motor. Okay, right. Very basic problems. So in order to understand three-phase induction motor problems, majorly you would be requiring two formulas. Okay, the first formula is FR. FR is equal to slip times stator frequency. This is the first formula what you will be requiring. Okay, and the second formula is slip. Slip is ns minus nr divided by ns. And the third formula is F is equal to 120 ns by P. Okay. So only these three formulas are required to solve induction motor problems. All right, fine. So let us consider the first problem. Copy the problem. A three-phase four-pole 440 volt 50 hertz induction motor runs with a slip of 4%. Runs with a slip of 4%. Find the rotor speed and frequency of rotor current. So find the rotor speed. So rotor speed is nr and frequency of rotor current. So this is what is asked. So what is it given? It is given that a three-phase induction motor consisting of 4 poles operating at 440 volt 50 hertz AC supply. And the slip of the induction motor is 4%. And you are supposed to find out the rotor speed nr and the frequency of induced EMF in the rotor Fr. So fine. Let us solve the problem. Solution. Okay. So first let us find out, let us make use of slip formula. Okay. What is slip? Slip is 4%. Okay. So 4% is 0.04. And what do we have? The formula for slip. We have formula for slip as ns minus nr divided by ns. Okay. Do we know anything about ns? No, we don't know anything about ns because nothing is given in terms of synchronous speed. But you can calculate ns. Ns is 120 F by P. Ns is 120 F by P or 120 into F. What is F? Frequency 50 hertz divided by P. P is equal to 4. So Ns is 1500 RPM. Ns is 1500 RPM. Once Ns is known, you can find out Nr. So from this, you can cross multiply and you can say that 0.04 Ns, 0.4 into Ns is equal to Ns minus Nr. Or let me take Nr this side and this Ns on the right hand side. Okay. So what do I get? Okay, so I get Nr is equal to Ns minus 0.04 Ns or NR is equal to NS into 1 minus 0.04. Okay. So one standard formula, I can write it here itself. So rotor speed NR is always equal to synchronous speed NS into 1 minus slip. Right. So this is 0.04. What is 0.04? 0.04 is the slip value. Okay. So this is my standard form. You can highlight this form. NR is equal to NS into 1 minus S. All right. So that will give me NR value. So NR is equal to NS, that is 15,000 RPM, 1500 RPM into 1 minus 0.04. Okay. So how much you'll get? 1440 RPM. So NR is equal to 1,440 revolution per minute. Okay. So that is my NR. So NR we have found. Okay. Now let us find the value of FR. So FR is equal to slip times F, or FR is equal to slip value, which is 0.04 into F. What is F? 50 Hertz. So FR is equal to 0.04 into 50, that is 2 Hertz. Very simple problem. Induction motor and synchronous generator module is very, very simple because you are using all basic problem. I mean, basic formula and very basic theory you are considering. Okay. It's very simple to score also. So that's it about your first problem. NR 1440 RPM and FR is equal to 2 Hertz. All right. So that's about problem number 1. Now let us look at the second problem. Okay. Copy the problem. It is given that the frequency of the EMF in the stator of a 4-pole induction motor is 50 Hertz. It is given that the frequency of the EMF in the stator of a 4-pole induction motor is 50 Hertz. And that in the rotor is 1.5 Hertz. And that in the rotor is 1.5 Hertz. What is the slip? What is the slip? And at what speed the motor is running? What is the slip? And at what speed the motor is running? Okay. So how will you solve? Now, you know stator frequency, 50 Hertz, and you know rotor frequency, that is 1.5 Hertz. The stator frequency and rotor frequency are related by slip, right? So rotor frequency FR is slip times F, or slip is equal to FR divided by F. That is equal to, what is FR? 1.5 Hertz. divided by F 50 hertz. 50 hertz. So the ratio gives slip as 0.03. The ratio gives the slip value as 0.03. So first part you have calculated 0.03 slip. Now let us come to the second part. Okay. Now in the second part we have seen that. Okay. So this I am telling from the previous problem. In the previous problem, we saw that NR can be written as NS times 1 minus S. Right? We can make use of this formula to determine NR. All right. So therefore, NR is equal to NS. What is NS? NS is 120 F divided by P, or 120 into 50 divided by 4. Right? Frequency is 50 and number of poles are 4. So basically you will get 30. So NS you will get it as 1500 RPM. 1500 RPM. Substitute that here. So 1500 into 1 minus 0.03. Multiply and get the value of NR. How much will you get? 1455 RPM. 1455 RPM. So that's your second problem. Just go through with problem number 1 and problem number 2, because I want you to pay attention to especially module 5, because module 5 you can score out of out in externals. Very simple. So if you have any doubts, just let me know. If you don't have any doubts, I can take up problem number 3. All right. So, copy the question. Third problem. A 6-pole induction motor is connected to 50 hertz supply. A 6-pole induction motor is connected to 50 hertz supply. Full stop. It is running at a speed of 970 RPM. It is running at a speed of 970 RPM. Okay, I will not write whether it is NR or NS. I'll just write 970 RPM. Because whether it is NR or NS, I'm going to ask you. Alright. So it is running at 970 RPM. Full stop. Find the synchronous speed and the slip. Okay. Find the synchronous speed and slip. No suspense, right? Because they have asked you to find out the synchronous speed. So it is understood that this has to be the motor speed. Remember one thing. Motor speed or rotor speed is one and the same. Motor speed is nothing but is equal to rotor speed. Okay. and this is taken as NR. On the other hand, rotating magnetic field speed or stator magnetic field speed is nothing but ns. Okay. Sometimes they say speed of RMF is 1440 RPM. So speed of RMF is nothing but rotating magnetic field. So rotating magnetic field is always associated with stator winding. So that is taken as ns. Okay. So I want you to be very clear about the meaning of NR and the meaning of NS. All right. Fine. Okay. Let's go ahead with the problem. So, all right. So NR is given, and you need to determine NS and slip. Let's solve. So NS is found using the formula 120 F divided by P, or 120 into F. What is F? Frequency. 50 divided by P. P is equal to 6. So I think it is 1000 RPM. So synchronous speed or RMF speed is 1000 RPM. So next we have the slip. Now slip and slip synchronous speed can be interrelated, right? Slip and synchronous speed can be interrelated. We have slip is equal to ns minus nr divided by ns, or ns is 1000 rpm minus nr is 970 rpm divided by ns 1000 rpm. So basically 30 by 1000, that is 0.03. So the value of slip is 0.03. Do you have any unit for slip? No unit, right? Because numerator is expressed in RPM, denominator is also expressed in RPM. So RPM gets cancelled, so you will get a dimensionless quantity. So slip is always dimensionless. So you have found NS as well as you have found the slip value. All right, so that is your problem number 3. Fourth problem. So far, so good, right? Fourth problem. Let's see whether it is similar to the first 3 problems. Right on. A 10-pole induction motor. A 10-pole induction motor is supplied by a 6-pole alternator. Is supplied by a 6-pole alternator, which is driven at 1200 RPM. A 10-pole induction motor is supplied by a 6-pole alternator, comma, which is driven by 1000, okay, driven at 1200 RPM, full stop. If the motor runs with a slip of 3%, if the motor runs with a slip of 3%, what is its speed? What is its speed? How do you solve this? If it was direct interaction, I would have conveyed this in a better manner. Okay, due to non-direct interaction, even I'm finding it little difficult to convince you guys. Now, In this problem, you can hear about two machines, right? 10-pole induction motor is supplied by 6-pole alternator. So to solve this particular problem, it is better you throw some more light on the data. Okay. So what you have an alternator. So this is your alternator. What is alternator? Alternator is nothing but a generator. So the induction motor, this is your induction motor. Induction motor. So induction motor is supplied by alternator. That means to say, this is your stator. R, Y, B. So basically, the alternator is supplying electricity to induction motor, right? Because motor needs electrical power input. Fine. What is the specification? With respect to induction motor, they have told 10-pole induction motor. So under motor, you write number of pole is equal to 10. Is supplied by a 6-pole alternator. So under alternator, you write P is equal to 6. Because you have to properly distinguish the motor specification from generator specification. Okay. Let me repeat the problem statement once again. 10-pole induction motor is supplied by a 6-pole alternator. Okay. Which is driven at 1200 RPM. That means to say, this alternator, okay, is the rotor. The rotor is driven at 1200 RPM. So, alternator speed, which is also called as synchronous speed, is 1200 RPM. And then they have asked you to find the speed of the motor when it runs with a slip of 3%. So slip is 3% or 0.03. In bracket, let me write 3%. So for a slip of 3%, what is the speed of the motor? What is the speed of the motor? How will you solve this? Now, they have told the alternator runs at a speed of 1200 RPM. So, Ns is equal to 1200 for alternator. Can we take this itself as the speed of rotating magnetic field? Can anyone tell me? Or the speed of rotating magnetic field is different? Can anyone tell me? Is it the same or different? And people have just given the attendance and vanished. Okay, no problem. Fine. So this speed is related to the rotor. Now, if you see here, your alternator shaft is not connected to motor shaft. No. The alternator shaft is connected to the prime mover, right? Such as water turbine or steam turbine. So this speed is different from the synchronous speed of alternator. So synchronous speed of alternator, you need to find out from the synchronous speed of induction motor, you need to find out from motor specification. Okay. So let us write synchronous speed of induction motor is given by Ns. So Ns is equal to 120 F by P. So that is equal to 120 into F I don't know, P I know 10. Now, what is F? This is F. So, what is F? How will you find out F? F can be found. F is nothing but, okay, where F is equal to frequency of supply, where F is equal to frequency of supply. That is frequency of alternator power output. That is the frequency of alternator power output. Makes sense, right? Because alternator supplies electricity to the induction motor. So if you can calculate the frequency of induced EMF of alternator, you will be able to find the F. So F can be found from the alternator data. Okay, F is P into Ns divided by 120, or alternator poles are 6 into Ns is 1200 divided by 120. So F is equal to 60 hertz. 60 hertz. So substitute there. 60. So what do you get? The synchronous speed as 720 RPM. So you will get the synchronous speed of induction motor as 720 RPM. Once synchronous speed is known, you can find the rotor speed. Right? This is what you are supposed to find out. NR is equal to 1 minus S into Ns. So that is 1 minus 0.03 into 720, or NR is equal to 698.4 RPM. NR is equal to 698.4 RPM. So that is the solution. So this is a very important problem. All right. Quite often, students, they make mistake by considering Ns of alternator as Ns for induction motor. No, this is wrong. Your induction motor will always be having different synchronous speed that needs to be calculated separately with the following formula. Okay, but when you calculate the synchronous speed of the induction motor, make sure that you substitute the frequency from the alternator data. All right. So that's your problem number 4. Okay. 5th problem you consider. Write down the 5th problem. A 4-pole 50 hertz induction motor has a slip of 1% at no load. Full stop. When operated at full load, the slip is 2.5%. When operated at full load, the slip is 2.5%. Full stop. Find the change in speed find the change in speed from no load to full load. Find the change in speed from no load to full load. So it refers to an induction motor with P is equal to 4 and F is equal to 50 Hertz, which has a slip of 1% at no load. You can write at no load, S is equal to 0.01 or 1%. But on full load, the slip becomes 2.5%. But at full load, slip becomes 0.025%. Okay, that is 2.5%. Find the change in speed from no load to full load. So you need to find change in speed from no load to full load. So since you are supposed to find out the speed difference from no load to full load, let us consider let NR naught is equal to no load speed. Because there are two cases, right? No load and full load. Let us say NR naught is equal to no load speed and NRL is equal to full load speed. Full load speed. So what you have to do is you have to find out what is that NR naught and what is that NRL. So if you find these two values, you can take out the difference and you can find out the speed difference. Okay. So how will you solve? So first what you can do is, first you can take no load condition. Okay, first you can take no load condition. So first let us find out the synchronous speed because it is not given. So Ns is equal to 120 F by P. 120 into 50 divided by 4, so 30. So synchronous speed is 1500 RPM. Synchronous speed is 1500 RPM. Once synchronous speed is known, you can find out NR naught. So NR naught is 1 minus S into Ns. So 1 minus S is 0.01 into 1500 RPM. So that will give you NR naught. So how much is NR naught? 1 minus 0.01 into 1500. 1485 RPM.
1485 RPM.
Right, 1485 RPM. Correct. Okay. So once that is done, you can go to the full load condition. So under full load condition, you have different slip. So with respect to this slip, you are supposed to find out the rotor speed. So NRL we have taken, right? The rotor speed under full load condition. So NRL is equal to 1 minus S into Ns or 1 minus 0.025 into 1500 RPM. So NRL, you will get it as 1 minus 0.025 into 1500. 1462.5. 1462.5 revolutions per minute. So what you have found NR naught and you have found NRL. So once these two speeds have been found out, you can find the change in speed. So therefore, you can write, therefore, change in speed delta NR, change in speed delta NR is equal to NR naught minus NRL. So that is 1485 minus 1462.5. So therefore, delta NR, delta means small change in, right? The small change in speed basically. Subtract the two. It is 22.5 RPM. So change in speed is just 22.5 RPM. One question. Any guess which type of motor it could be? Is it a squirrel cage induction motor or slip ring induction motor? Any guess? We have two types of induction motors, right? Squirrel cage, which is called as constant speed motor, wherein the speed difference is not much. On the other hand, you have a slip ring induction motor, which can be used for variable speed application. So in this problem, as you can clearly observe, that no load speed is 1485 RPM and full load speed is 1462 RPM. So there is not much change in the speed from no load to full load condition. You understand the no load and full load condition? You consider an example of mixer grinder, right? So let's say you want to grind batter for, let's say, dosas. If you have an empty jar, that is called as no load because you haven't put any load onto the motor blades, right? On the other hand, the moment when you mix, when you fill, let's say, rice, everything into the mixer jar, then you can say that there is some load put onto the motor blade. So under no load, mixer grinder will run at very high speed. Correct? The moment when you put the batter into the mixer grinder, what happens? The mixer grinder starts to rotate at a lower speed. So always when the motor is loaded, the motor runs at a lower speed. But in this particular problem, you are observing an very important data, that is the speed change from no load to full load is minimal. So this type of motor has to be squirrel cage induction motor. Squirrel cage induction motor. Now, why am I asking you this particular question? It is not the part of this question, but in your lab exam, MCQ, right? They can ask this type of questions. Okay. Identify the motor which is rotating essentially at constant speed. Squirrel cage induction motor, slip ring induction motor, both A and B, none of these, such options may be asked. So you have to say that it's a squirrel cage induction. So that's your problem number 5. One last problem on it. Solve. Okay, you can even consider the bike condition, right? When only the rider sits on the bike can be driven at a faster speed. On the moment, when you take, let's say, 2-3 friends along with you in your bike, what happens? The bike will not accelerate at higher speed. That means to say there is more load put onto the engine. So when the load increases, speed drops. On the other hand, when the load decreases, speed increases. Sixth problem, let me see who will solve this. Copy the problem statement. A 12-pole, 3-phase alternator. A 12-pole, a 12-pole, 3-phase alternator is coupled to an engine running at 500 rpm. Is coupled to an engine running at 500 rpm. Full stop. It supplies an induction motor. It supplies an induction motor which has a full load speed of 1440 rpm. Which has a full load speed of 1440 rpm. Find the percentage slip and the number of poles of the motor. Find the percentage slip and number of poles of the motor. Okay. So what is it given? A 12-pole 3-phase alternator, right? A 12-pole 3-phase alternator is coupled to an engine running at 500 rpm. So alternator speed is 500. And the speed of induction motor is 1440 rpm. You are supposed to find out the slip and the number of poles. All right. Fine. So from the alternator data, probably you can find out the frequency. So frequency is P into Ns divided by 120. P is 12. Ns is 500 divided by 120. So F is equal to 50 hertz. So 50 hertz is the frequency of the induced EMF in alternator. So the same frequency is given to the induction motor. That's because your alternator supplies electrical power. P electrical. The alternator is voltage producing machine. It supplies electricity to induction. Now you need to find out slip and number of poles. Okay, fine. Now how will you find out slip? Percentage slip is Ns minus Nr divided by Ns into 100. Okay, this is how you calculate the percentage, right? Ns minus Nr, and when you multiply by 100, you will get the percentage. So to calculate percentage, you have Nr value, which is 1440 rpm, but you don't have Ns value. Hence, you need to determine Ns. How will you determine Ns for induction motor? 120 F divided by P. That is equal to 120 alternator data divided by P. We don't know because P needs to be found out. So in your Ns relation, you have two unknowns, right? Speed is also unknown. Number of poles are also unknown. So how will you solve this particular problem? Can you assume? Yes, of course you can assume, provided you have a strong defense for your assumed data. So what you have to do in this particular problem is that you have to calculate ns for different combinations of p. And for each combination of p, you need to determine slip. Okay, let's do that. So what I will do, I'll make a small table. Okay, in the table, let me do something like this. Let us call this as p, number of poles, and we'll calculate ns, and let us calculate percentage slip. Okay, I've given the formula, right? Percentage slip is here, ns minus nr divided by ns into 100, and ns is 120 f by p. Okay. So let's do it. So you know that poles cannot be odd numbers, right? It should be an even number. 2 poles, 4 poles, 6 poles, because you should have a pair of poles. For every north pole, you should have a south pole. All right. So first, let us take p is equal to 2. When you take p is equal to 2, what do you get the synchronous speed as? Synchronous speed, you will get it as 120 into 50 divided by 2. That is 3000 RPM. 3000 RPM. Now, 3000 RPM gives, what slip value? So 3000 minus 1440 divided by 3000 into 100. 52%. Okay. Let us change it to 4 now. So when you change it to 4, speed becomes 1500 RPM. And for 1500 RPM, slip is 4%. And now let us change it to, let's say, 6. Let us see what we will get when we change it to 6. When we change it to 6, we will get thousand. So you'll get the slip value as minus 44%. And you can go on. So if you go on, what will happen? You will keep on getting negative slip. And then finally remarks. So what is that optimum combination of number of poles gives the valid results? Now in the very beginning I said the air gap is very, very small in case of induction motor because you need to achieve a good mutual induction. Alright. Now if you set P is equal to 2, what are you getting? You are getting very large slip. Very large slip means there will be huge losses in the induction machine. Okay, large slip corresponds to basically large air gap. So if air gap is large, then there will be huge losses in the machines. So 52% slip value is very, very bad. Very, very bad. So we cannot set P is equal to 2. All right. I'll skip P is equal to 4 for a while. Let me go to P is equal to 6. But if we select the number of poles as 6, what is happening is you are getting a very high slip value, but it is negative. But in the yesterday's lesson, we have investigated the slip variation, right, against your rotor speed. Negative slip you can get only for generator operation. Negative slip you can get only for generator operation. But here we are talking about a motoring operation. So for a motoring operation, how can you get a negative slip? So case 3 is also invalid. So only case 2 looks valid because P is equal to 4 gives a very small slip value. Okay. So probably here you can write the conclusion that a practical induction motor, you can write it along with me, a practical induction motor runs at a very small slip value. In bracket you can write as small as 3% or less. As small as 3% or less. So in this particular problem, the optimum pole combination is P is equal to 4. That can give percentage slip as 4%. 4%. So that is the solution for this particular problem. All right. So what I will do, I will stop here. So this is the 6th problem. So in the next class, let me take up the last portion in 3-phase induction motor. That is starters used in 3-phase induction motors. Okay, those 3-phase induction motors are self-starting because of some reasons. You know, it is better if we start the induction motor using starter. All right. So that let us see in the next class. So in the next class, let me finish starters as well as let me solve say 2 to 3 problems. Okay, that should complete our module 5. Okay, in the next class. Thank you so much.